NASA didn't expect this. On December 3rd, during a quiet observation window, one of their high-resolution infrared scans returned a structure that shouldn't be possible around 3I Atlas, a faint arc, a circular ring, symmetrical, coherent, stable. This isn't a tail. This isn't debris. This is something else, and it changes everything. If you've been following the journey of 3I Atlas through our solar system, you already know this isn't a typical interstellar object. Its trajectory is too clean, its behavior is too calm. But now, with this ring-shaped anomaly emerging in the data, we have a new question, one that goes beyond composition or velocity. How does a fast-moving comet from another star system form a perfect ring? The answer isn't in theory, it's in what we're seeing, and we're going to walk through it together. It began, like most things in modern astronomy, with a data set nobody expected to matter. December 3rd, just after 8:04 hour UTC, a thermal anomaly appeared in a frame taken by NASA's Goldstone Deep Space Complex. The scan was part of a scheduled long-wave infrared pass optimized not for imaging, but for mapping heat dispersion across the coma of 3I Atlas. Nothing unusual was anticipated. The team running the software expected a diffuse thermal plume, a classic uneven distribution of heat caused by outgassing like every active comet before it. But that's not what they saw. The anomaly was flagged by the software first, not a human. An automated contrast enhancement tool highlighted a closed-loop shape, faint but perfectly symmetrical, circular, centered around the nucleus. The internal readout labeled it as a radial coherence anomaly, a label reserved for patterns too uniform to occur in turbulent environments like comet tails or fragmentation clouds. A ring. At first, the scientists overseeing the scan assumed a data artifact. Rings don't appear around comets, certainly not fast-moving interstellar objects with no known history of satellites, debris clouds, or collision remnants. And so, the first internal memo simply noted a visual inconsistency and recommended rerunning the scan through denoising filters. No urgency, no escalation, but the filters didn't erase the ring, they made it clearer. That same morning, the anomaly was confirmed, not just by Goldstone's thermal imaging, but by a second independent source, the Infrared Telescope Facility on Mauna Kea, Hawaii. Different angle, different instrument, same shape. The odds of two independent systems generating the same artifact were near zero. Still, the response was muted. The initial reports were routed through low-priority internal channels, flagged as non-urgent curiosity, and quietly parked for further review. But not everyone accepted that framing. One junior astrophysicist at JPL, who had worked on planetary ring dynamics, noticed something the others hadn't. The ring wasn't simply present, it was phase-locked, its position relative to the comet's spin axis appeared consistent across multiple frames. In other words, it wasn't drifting like debris. It was maintaining orientation. That changed everything. When this was presented during a closed-door data review, later that day, the tone shifted. Suddenly, what was dismissed as a sensor artifact was now an unresolved structure, a ring-shaped thermal halo that rotated with the object. The analysis was still raw, but it raised difficult questions. What natural process could produce a symmetric structure this stable around an object without any of the physical prerequisites for a ring? Where was the dust? Where was the breakup event? Why wasn't it visible in optical? The meeting ended with no official conclusion, just a consensus to withhold comment. The data would be internally circulated to confirm whether the feature was persistent in upcoming passes. But even that decision reflected unease, because the real question wasn't about validation. It was about implications. Rings in nature are fragile. They require parent bodies large enough to exert meaningful gravity, like Saturn or Uranus, or at the very least, shepherd moons to keep the particles in check. But 3I Atlas was barely large enough to sustain a coma, and it had no known satellites. The physics didn't add up. And that's what made this discovery quietly terrifying. The final internal memo of the day used a phrase no one expected to see associated with a comet: unexplained coherent rotational ring. It wasn't published. It wasn't leaked. It was locked behind clearance level access. But from that moment on, the mood around 3I Atlas shifted. This wasn't just an interstellar object anymore. It was something else. And now the people watching it were no longer just observing a comet. They were watching a structure. Once the infrared anomaly was logged, the next logical step was to triangulate. Optical telescopes couldn't see the ring. The coma of 3I Atlas remained visually unremarkable, faint, white, unresolved. But radar, with its ability to bounce signals off solid surfaces and return echoes with sub-millimeter precision, offered something else: geometry. 2 days after the initial thermal ring was flagged, a coordinated radar sweep was executed by the Deep Space Network, using the Canberra and Madrid stations in tandem. The goal was simple: map rotational wobble and see if the object's surface irregularities could explain the infrared symmetry. What came back wasn't an explanation, it was a pattern. The radar returns displayed something so unusual that at first the system flagged it as a corrupted ping loop. In every sweep, a faint secondary echo bounced back, offset from the main nucleus echo by a consistent radial distance. This wasn't atmospheric interference. It wasn't a trailing debris cloud. It was a ringed return, an annular echo. Something was deflecting radar energy around the nucleus in a fixed circular profile, and it repeated. Every rotation, every angle, every pass. The ring wasn't just present, it was coherent. The analysis team tried to model the echoes using known cometary shapes. Maybe it was a wide coma density band, maybe a field of debris orbiting the core, but no model matched the data. The echoes were too clean, too sharp. A natural dust halo would have produced diffusion, fuzziness, scattering, but this return had definition. One radar technician noted the anomaly behaved like a toroidal frame, referencing the shape used in tokamak reactors, donut-like magnetic fields engineered to hold plasma. That wasn't meant to be literal. It was just the closest analog in the physical world to what the radar data implied. To be clear, this didn't mean the ring was made of metal or artificial material. There was no reflection spike, no beam doubling. The signal didn't saturate like it would with solid composites, but it did return a consistent contour, something wide, hollow, equidistant from the center. The team began calling it the shadow band, not because it was dark, but because it was quiet. The ring absorbed just enough radar energy to soften the return, creating a measurable dip, a donut-shaped null zone that appeared again and again no matter the beam's origin point. At this stage, silence became protocol. No outside observatories were briefed. No public logs were published. Internally, though, debate exploded. Was this a shell of dust, gravitationally bound to the comet? Unlikely. The trajectory of 3I Atlas was too fast, its mass too low. Could it be a magnetic dust trap? The object had shown no signs of significant electromagnetic interaction, and then someone asked the question that shifted the room's atmosphere. What if the radar isn't bouncing off dust, but structure? That term, structure, changed everything. It didn't imply artificiality, but it introduced intentionality. A ring implies design, and in space, design usually implies one of two things: formation or deployment. If the ring had formed naturally, it should be irregular. If it had been deployed, then what were we really looking at? The final cross-check came from an unexpected source: amateur radar pings from a decommissioned dish in Eastern Europe. Though lower in resolution, their data showed the same radial band, blurred but unmistakable. It meant this wasn't an equipment error. It wasn't calibration noise. It was real. Whatever circled 3i Atlas, it wasn't temporary. It wasn't chaos. It was stable, persistent, and responding to high frequency radar in a way nothing natural should. From that moment on, the team tracking this object began using a new internal tag, closed orbital anomaly, repeating. It would take weeks for the implications to surface, but the ring had spoken and radar had listened. Rings require mass. That's the rule. Whether you're looking at Saturn's brilliant bands or the faint, narrow loops around Chariklo and Haumea, the mechanics are always the same. A central body, massive enough to anchor debris in a stable orbit, must serve as the gravitational well. Without that, particles drift. The ring dissipates. It's orbital physics, simple and universal. 3i Atlas doesn't fit the equation. Measured estimates put its size between several hundred meters to a few kilometers wide, barely large enough to form a coma, let alone sustain a ring. It has no known satellites, no magnetic field, no shepherd moons, and yet, as of December 3rd, it is encircled by what appears to be a structured, symmetrical ring. That fact alone has sent scientists scrambling. In the wake of radar confirmations and infrared detections, the question is no longer if the ring exists, it's how. And the first hypothesis, that it formed through fragmentation, immediately hit a wall. Rings caused by impacts or breakups are chaotic, irregular. The particles spread unevenly and follow eccentric orbits, leaving trails and turbulence that are easy to spot. But 3i Atlas shows no signs of a recent event. No plume, no trailing debris, no mass loss, just a clean, consistent torus. So, where did the material come from? Some proposed that the ring is not made of particles at all, but rather composed of gas, gently ionized and temporarily suspended by electrostatic interactions. That theory, however, required a magnetic field to shape the plasma, and 3i Atlas has shown no magnetosphere, no radio pulses, no hint of magnetic confinement, and even if such a field existed, it would likely be unstable at the object's current velocity and trajectory. The ring is too consistent, too anchored. Others turn to sublimation mechanics. Could jets of gas erupting from opposite sides of the rotating nucleus create a symmetrical halo that mimics a ring? Possibly, but again, there's no visual or thermal evidence of such jets, no bright spots, no outbursts, no motion inconsistent with simple coma behavior. The ring isn't an illusion caused by sunlight or vapor. It's holding shape even in shadow. That led to the next possibility, self-assembly. Could particles have gradually migrated into a ring formation as the object passed through the solar system? Could gravitational interactions or rotational forces sort them into place? This idea found early traction. Debris disks, after all, do form around stars, and the thin rings of Chariklo exist without a massive planet to hold them. But here's the issue. Those bodies are static, long-term residents of the solar system. 3i Atlas is not. It is moving at interstellar speeds. It is not orbiting the sun. It is passing through. There's been no time for particles to settle, for forces to equilibrate. The ring either existed before it entered the system, or it formed all at once, very recently. And that's what makes this object so problematic. It has no parent body large enough to account for the stability of its ring, no companion moons, no anchoring mass, nothing to justify what we're seeing through any known natural process. If it was a fragment from an earlier generation system, we'd expect it to be torn apart by now, but it isn't. It's intact, more than intact. It's consistent. The ring rotates with the nucleus. Its orientation is phase-locked. It's not drifting. It's not collapsing. This has forced some researchers to entertain more exotic possibilities. Could the ring be synthetic? A shell of material deployed intentionally around the core? Is it structural? Is it energy-based? Or are we witnessing a configuration of matter and motion that simply hasn't been modeled before? Whatever the answer, one thing is clear: the rules that govern planetary rings do not apply here, because this ring has no planet, and this parentless structure just rewrote the playbook. One of the first assumptions made about the anomaly encircling Three Eye Atlas was simple: it must be a tail. After all, tails are common, expected even. Every active comet generates them. Solar heat causes surface ice to sublimate into gas, which erupts from vents and fractures, dragging fine dust particles with it. Solar wind then pushes this material away from the nucleus, forming long, glowing trails across the sky. These tails are dynamic. They stretch, curl, break, and reform as the object moves. Some curve dramatically, others split into dual structures, ion tails and dust tails. It's beautiful, chaotic behavior, but the ring around Three Eye Atlas doesn't behave like that, not even close. To begin with, it doesn't stretch. The anomaly isn't aligned away from the sun like a classic tail. It doesn't trail behind the comet. It doesn't flow. Instead, it forms a closed, equidistant circle around the object's midsection, coplanar with its rotation axis. That alone rules out most standard tail mechanics. Solar radiation pushes outward, but this structure hugs tight. That's not a tail, that's containment. Then there's the matter of directionality. Traditional tails always point away from the sun due to the force of solar wind and radiation pressure. Even when a comet is traveling away from the star, its tail still faces backward toward it. But the ring on Three Eye Atlas shows no such behavior. Observations taken at multiple points in its orbit show the structure remaining in the same relative position, locked around the nucleus like a belt, not drifting behind like a banner. It doesn't reorient, it doesn't warp, it doesn't care where the sun is. That's not tail physics, that's geometric stability. The third discrepancy is motion. Tails move. Even in short observational windows, high-speed imaging shows constant motion in tail structures, streams of particles shifting position, reacting to fluctuations in the solar wind, buffeting, breaking apart. But this ring remains unnervingly still. Radar returns across a 48-hour window in early December show no measurable drift. The ring maintains its shape and distance with less than 1% deviation. No natural tail made of loose particles or gas could sustain that kind of precision. What about composition? Surely a tail composed of highly uniform particles could form a pseudo-ring. That's been observed in rare cases where a jet points sideways and rotates with the object, but even those are fleeting, torn apart by the same forces that create them. And Three Eye Atlas has shown no outbursts, no directional jets, no increase in coma brightness to explain active gas emission. The core remains dark, quiet, cold. There is no engine to fuel a tail, no pressure to maintain one. And then there's the problem of symmetry. Natural tails, by definition, are asymmetric. They trail in a single direction. Even in comets that spin or tumble or change orientation, tails always find the path of least resistance, away from the sun. But this ring is symmetric, perfectly centered, a 360-degree structure that closes on itself without deviation. It doesn't bend, it doesn't taper, it doesn't feather out. It stays locked around the object's waist like an equatorial band. That symmetry is the final clue, because it suggests containment, confinement, an organizing force beyond simple gas dynamics. And that's where theories begin to break down. Some researchers have hesitantly proposed an electromagnetic ring, charged particles stabilized around the comet by a transient magnetic field. Others suggest it could be a rotating debris field, the remnants of a long-lost satellite or core fragment, but none of these match the data. None account for the stability, the shape, the silence. And so the conclusion becomes clearer, not because we want it to be, but because the evidence keeps pointing in the same direction. This is not a tail. It doesn't flow. It doesn't trail. It doesn't react. It holds. And whatever it is, it's not what comets are supposed to carry. Debris is messy. In space, it's unavoidable, whether from a natural fragmentation, a collision, or even sustained outgassing. Debris follows any event that disrupts a body in motion. You can't hide it. Dust, shattered rock, microfragments, they scatter and they leave fingerprints. Astronomers have studied hundreds of comets and asteroids that show clear signs of breakdown. Each time, there's a trail, a widening fan of particles that tells a story of violent separation. But around 3I Atlas, there's nothing, no debris, no fragments, no evidence of a collision or collapse. And yet, there's a ring. This is the paradox that's quietly rewriting the rules behind closed observatory doors. If a ring like this one formed naturally, it would almost certainly originate from a disruption event. Maybe the surface layer collapsed due to internal pressure. Maybe a minor satellite disintegrated. Maybe an ancient impact shattered a section of the core, spreading debris into orbit. That's how rings form in our solar system. Chariklo has rings, narrow arcs formed from collision debris, likely held in place by shepherd moons. Saturn's rings are made of countless ice particles, broken apart from moons or comets that ventured too close. Even the faint rings of Jupiter and Neptune have roots in disruption. So naturally, when a ring-like structure was detected around 3I Atlas, researchers began looking for the fingerprints of such a past event. They found none. The surrounding coma remains optically and spectrally clean. No secondary particles, no reflective dust halo, no infrared hotspots that would suggest recently exposed surfaces, and more importantly, no decaying or drifting structures in the vicinity. If this ring came from something breaking apart, the rest of that material had to go somewhere. But it didn't. Multiple deep sky surveys, including data from the Subaru telescope in Hawaii and the VLT in Chile, scanned the surrounding region. Nothing, no cloud, no gradient of particles widening with distance, not even a faint glow, just the nucleus and the ring. Radar sweeps confirm this absence. No clumping, no scatter echoes, nothing hiding in the shadows or on alternate trajectories. The space around 3I Atlas is clean, unnaturally clean. That's not just rare, it's nearly impossible. Even in comets that aren't fragmenting, minor particles are always escaping. Radiation pressure alone is enough to free microdebris from the coma and scatter it into space. Over time, those particles spread, creating visible tails or halos detectable with long exposure instruments. But with 3I Atlas, it's as if nothing is escaping. No fragmentation, no trailing arc, no off-axis clusters. It's self-contained. That leads to a deeper question. If the ring isn't debris left over from an event, is it being actively maintained? The idea is unsettling. It suggests not only that the ring is coherent, but that something is preventing it from degrading. There are no signs of dispersal, no widening of the structure over time. Measurements taken 5 days apart show no meaningful change in diameter, density, or signal strength. Even at its current velocity, even while drifting through a dynamic gravitational field, the ring remains stable. Could it be bound by gravity? Unlikely. The mass of 3I Atlas is too low. Could electrostatic forces be in play? Perhaps, but then we would expect variations based on solar proximity or interaction with solar wind. We don't see that either, just silence, just structure. And so the mystery deepens. The ring is there, but the origin event is missing. The particles that should surround it aren't present. The fragments that would complete the story never appear. What's left is a contradiction, a structure that looks like debris but behaves like a mechanism. No tail, no dust field, no scattered trail, just a ring holding its shape, surrounded by nothing. One of the most surprising discoveries about the ring surrounding 3I Atlas came not from imagery, but from timing. Across a series of time-lapsed observations, scientists began to notice something subtle but persistent. The ring wasn't just glowing in infrared, it was moving, rotating, not at random and not freely, but with a measurable, consistent rhythm. At first, the evidence was circumstantial. Small changes in the intensity profile were noted across thermal scans taken several hours apart. The brightest portions of the ring would shift slightly, not disappear, not flicker, but slowly slide around the perimeter. The changes were subtle, almost imperceptible in real time, but when the data was layered and accelerated in time lapse sequences, a pattern emerged. The ring wasn't static, it was rotating around the nucleus of 3I Atlas slowly, smoothly, predictably. The implications were immediate and unsettling. If the ring were made of gas or loose dust, it wouldn't rotate as a whole. Particles in a coma orbit independently. Some spiral out, others get pushed away by solar wind. But this structure wasn't dispersing. It wasn't radiating away like a jet. It was holding form, and now it was turning. The next step was to quantify it. Using Doppler shift measurements from narrowband radar returns, researchers detected a measurable velocity gradient. One side of the ring showed a slight redshift, the other a slight blue shift. That meant motion, rotation, and not just drifting particles, bulk motion of the entire structure, rotating in sync with the comet's own spin, but at a slightly different rate. This was not chaotic tumbling, it was controlled motion. The data suggested the ring completed one full rotation, roughly every 11 hours, slower than the estimated spin rate of the nucleus itself. That mismatch, called a rotational offset, was small but significant. It meant the ring wasn't physically bound to the surface, it was orbiting the comet like a belt hovering slightly off the waistline, trailing just behind the core's own motion. This changed everything. If the ring were a product of random debris, its rotational pattern would be inconsistent. It would speed up, slow down, break apart. But that didn't happen. The structure maintained a near constant angular velocity. More importantly, it didn't drift away from the comet's center line. Its distance from the core remained steady within the measurement margin of less than 1%. That level of rotational stability strongly suggests one thing: cohesion. Whether through gravity, electrostatics, or some unknown mechanism, the ring is staying in place and rotating with the object, almost like a halo in lockstep. And yet it's not fully locked. It trails slightly, as if it's tethered but loose, the kind of offset you'd expect from a mechanism designed to maintain separation rather than something collapsing inward. Some researchers have drawn analogies to synchronous orbiting bodies. Think of geostationary satellites around Earth. They hover over the same point, but only if perfectly tuned. The ring's motion resembles something approaching that kind of balance, not exact, but close enough to suggest intentional equilibrium. Here's what's even stranger. As the object's spin axis precesses slightly, wobbling due to thermal forces, the ring corrects. It adjusts position subtly over time, not rigidly, not like a mechanical part, but like something responding to the gravitational or inertial frame of the comet, as if it's programmed or naturally inclined to remain in place, a form of passive station keeping. This kind of behavior doesn't match any known natural rings. It doesn't match any known cometary coma, and it certainly doesn't match debris. Debris doesn't rotate in a shell. It scatters, it drifts, it obeys entropy. But this ring turns, not wildly, not erratically, deliberately, and that's the problem, because rotation implies momentum. Momentum implies force, and force, especially this precise, requires a source. Comet tails always follow the same rule. No matter the shape of the object, no matter its speed or origin, the tail always aligns in one clear direction: away from the sun. That's because comet tails are driven by solar forces, solar wind, radiation pressure, and outgassing jets that push material into space. The geometry is predictable, the orientation is solar dependent, but the ring around 3I Atlas is breaking that rule. Since the structure was first detected in infrared on December 3rd, multiple observatories have confirmed something extraordinary. The ring is not oriented toward the sun. In fact, it's consistently aligned in the opposite direction. It doesn't face solar radiation. It hugs the object's shadow zone, and it stays there no matter how the comet moves. That makes no sense under conventional models. If the ring were made of outgassed particles, they should be pushed outward from the sunward side. They would naturally flow in the direction of the solar wind, creating asymmetry, bending the structure into a fan or trailing arc. We've seen this in every active comet ever recorded, but in this case, the structure is centered around the dark hemisphere, almost as if it's avoiding the sun altogether. That puts it squarely in what's known as the anti-solar vector, the side of the object that receives the least energy, where solar pressure is weakest. That behavior is the opposite of what we expect, and it's not subtle. Thermal imaging confirms that the ring's brightest band is consistently oriented away from the sun, no matter where the object is in its orbit. That's not random positioning. That's tracking. Intentional or not, the ring appears to be actively maintaining a position where solar exposure is minimized. Why would a natural structure do this? There are no known cometary processes that push particles into the shadow zone and keep them there. Gravity is too weak. Radiation pressure would force them out, and even if a gas jet somehow propelled material backward, it wouldn't stabilize into a symmetric shape. It would dissipate quickly, forming a directional tail like every other comet. This behavior suggests that the ring is either resisting solar influence or shielding itself from it. One theory proposed in an internal memo at the European Southern Observatory posits a form of passive magnetic drag, an interaction between charged particles and the object's own micromagnetic environment. But there's a problem. 3I Atlas has shown no magnetic field strong enough to produce this effect, no deflection of solar wind, no radio emissions, no polarization signatures. Another theory suggests that the ring is comprised of high molecular weight compounds, dark, radiation-resistant material that clumps in the object's gravitational lee. This would explain its optical invisibility, but not its geometric precision. Nor would it explain the ring's dynamic behavior, like its rotational drift or thermal consistency. That brings us back to orientation, because this isn't just strange, it's strategic. By hugging the shadow zone, the ring minimizes heat absorption. It reduces exposure to ionizing radiation. It avoids disruption by solar particles. These are the same principles used in spacecraft design. Components are often positioned behind protective shields to reduce solar wear and preserve sensitive instrumentation. And here, around an interstellar object moving at tens of kilometers per second, something is following those same principles. We don't know how the ring is doing it. We don't know why it's there. But we do know this: the structure is not random. It is not symmetric by accident, and it is not aligned with the sun. It's hiding on purpose or by design. The ring is positioning itself in the safest place possible, in the shadows. Comets, for all their mystery, follow patterns. Across decades of observation, astronomers have cataloged the spectral, thermal, and structural signatures of thousands of them. From short-period comets like 67P Churyumov-Gerasimenko to long-period wanderers like Hale-Bopp, the fingerprints are consistent. Composition, behavior, and shape all fall within an expected range, even when the object comes from the outer solar system. But 3I Atlas is something else. Its ring structure, the clean, symmetrical formation locked around the nucleus, isn't just unusual, it's unmatched. As of December 3rd, not a single known comet in recorded history exhibits anything remotely similar. And this includes both native and interstellar bodies. Let's start with Oumuamua. the first interstellar object ever recorded, it sparked controversy because of its unexpected acceleration and shape, but it showed no ring, no structured glow, no consistent thermal band surrounding its body. Its motion was puzzling, but its signature was that of a tumbling rock, dry, inert, silent. Then came 2I Borisov, the second interstellar comet. This one behaved more like a typical comet, with visible outgassing, a diffuse coma, and a predictable tail-forming trajectory. Its composition and light signature aligned closely with icy bodies from our own solar system. Again, no ring, no symmetrical infrared shell, no structural persistence. Now compare that to 3I Atlas. The thermal profile detected in early December is consistent across multiple instruments. It's not a blip, it's not a flare. It's a continuous, stable ring of emission, centered perfectly around the object's equator, visible only in infrared and completely invisible in optical wavelengths. This is not something we've seen before, and more importantly, it's not something our models can replicate. Cometary rings, if they exist, should be irregular, transient, caused by collisions or massive outbursts that scatter material into temporary orbit. We've seen faint arcs around Centaur objects like Chariklo and Haumea, likely formed from moonlit disruptions, but those are planetary-scale bodies. They have enough gravity to trap debris. 3I Atlas doesn't. There's also the rotational symmetry. That too is unprecedented. Every known comet emits particles asymmetrically. Jets form on the sunlit side. Dust spreads unevenly. No natural comet produces a perfectly balanced halo. Even the coma, when it expands, forms a diffuse cloud, not a rigid equidistant ring. Yet 3I Atlas's signature defies all of that. Its rotation is clean. Its thermal emissions are consistent. Its ring is centered, phase-locked, and stable. From a spectral analysis standpoint, the signature is just as strange. The emission curve of the ring does not match common volatiles like water vapor, carbon monoxide, or carbon dioxide, all standard outputs from icy bodies. The wavelength peaks fall in between, suggesting either unknown compounds or materials in a physical state we haven't yet observed in comets. And still the central mystery remains. No other object, natural or interstellar, has shown this. Not in thousands of observations, not in decades of comet science. That raises a critical question for planetary scientists. If no comet ever detected behaves like this, then is 3I Atlas a comet at all? It might have a coma. It might follow a hyperbolic path, but behavior defines classification as much as origin. And so far, every behavior we've observed is off the charts. Some institutions are already beginning to quietly relabel it, using internal tags like unclassified interstellar object or non-standard trajectory mass. It's the scientific equivalent of saying, we don't know what this is, but it's not what we thought. And that's where things get uncomfortable, because when the object you're studying no longer fits any category, you're no longer explaining it, you're observing it. And 3I Atlas, with its unmatched ring, has now become a singular data point, a signature without precedent, a shape without history, a comet without a class. When infrared imagery revealed a perfectly circular, rotating ring around 3I Atlas, aligned with its equator, phase-locked but slightly offset, scientists were quick to search for natural analogs. The shape was stable. The glow was thermal. The structure didn't scatter or dissipate like dust. It wasn't a gas tail. It wasn't a fragment belt. So a new theory began to circulate behind the scenes. Could it be a magnetic loop? At first glance, it sounds far-fetched. Magnetic loops are not common in comet science. They're associated with stellar activity, massive arcs of plasma looping from the surface of the sun, trapped and shaped by complex magnetic fields. But there's a reason this idea was raised. The behavior of the ring mirrors the logic of a magnetic structure, suspended, symmetric, and bound by invisible forces. Here's how the theory unfolds. If 3I Atlas has a magnetic field, no matter how weak, it could interact with solar wind in unexpected ways. Under certain conditions, charged particles in the environment might become trapped along magnetic field lines, forming arcs or loops that follow the curvature of the field around a rotating body. That could result in a toroidal structure, an energized spinning halo. And that's precisely what we see: a thermal ring, circular, rotating, stable in position. But the problem begins with scale. Comets do not generate strong magnetic fields. They are too small, too inert, lacking the molten metallic cores or convective layers necessary to power a magnetic dynamo. In our solar system, only large bodies like Earth, Jupiter, and the Sun produce active magnetospheres. Even then, they are chaotic, unstable, and often difficult to model. So how could a comet-sized object like 3I Atlas generate something similar? One idea is induction. As a body moves through the solar wind, electric currents can be generated if conductive materials are present beneath the surface. These can, in theory, give rise to transient magnetic fields. We've seen weak induced fields around asteroids and even comets before. Rosetta's mission to Comet 67P detected one, but it was barely measurable. Yet 3I Atlas isn't behaving like 67P. Its ring is clean, consistent, actively rotating. There's no sign of decay, no spiral of dispersion. It doesn't look like a transient arc. It looks like a stable magnetic structure. So if it is a loop, that implies one of two things. Either 3I Atlas possesses an internal source of magnetism that we've never seen in a comet before, perhaps through exotic composition or even an artificial mechanism, or the field is being imposed from the outside. Could the sun itself be shaping this ring? Could it be a solar interaction, something triggered at the moment of perihelion when solar wind pressure peaked? The issue here is motion. The ring isn't trailing the sun. It's not forming on the sunward side, where most magnetic interactions manifest. It's sitting on the shadow side, facing away from the sun, anchored to the equator, and rotating with the object's internal rhythm. That's not a solar loop. That's something closer to a magnetic harness. And then there's the shape. Magnetic loops, natural ones, flare. They rise, collapse. They flicker and evolve over time. But this ring remains unchanged. No flares, no decay, no shrinkage, just slow, synchronized motion around the object. Some suggest the structure could be a type of magnetic containment zone, a shell that traps particles and slowly emits energy, like a primitive magnetosphere. But that theory requires stable geometry and an internal power source, neither of which have been detected. So here we are again on the edge of what's explainable. If it's not dust, not rock, not ice, and not gas, if it doesn't behave like a tail, a coma, or a debris field, and if it moves like a magnetic loop but comes from something too small to generate one, then what exactly are we looking at? A ring, a glow, a loop without a source, and maybe without a name. When Avi Loeb first proposed that Oumuamua might be an artificial object, he didn't claim it was alien. He claimed it was evidence that our models were incomplete, that when something behaves in a way no natural object should, we shouldn't explain it away. We should investigate. With 3I Atlas, that same logic is now surfacing again. Loeb's name began circulating behind the scenes the moment the ring structure was confirmed on December 3rd. Not because he was directly involved with the discovery, but because the behavior of this object echoed the very questions he raised years earlier. Once again, an interstellar body was defying classification. Once again, its physical features didn't match any known comet, and this time the anomaly wasn't just in motion, it was in structure. According to sources close to the Galileo project, a team Loeb founded to investigate unusual interstellar phenomena, A preliminary analysis was quietly conducted using open data from December's early thermal readings. The result was a single question scrawled at the top of a shared document. What is maintaining this symmetry? That's where Loeb's hypothesis enters the conversation, not as a statement of belief, but as a structured chain of logic. It begins with the ring. Loeb has long argued that persistent structure in space, especially when it resists environmental decay, is the first red flag. Natural materials scatter, radiation erodes, gravity breaks apart. When a formation persists despite these forces, it suggests either constant regeneration or internal cohesion. Neither fits within existing comet science. Next comes the rotation. The fact that the ring is rotating with the object, phase locked but offset, suggests dynamic interaction, not passive debris. Loeb has pointed out in the past that such synchronization implies control. And in this case, there's no known way for inert particles to maintain such a stable orbital band without some kind of balancing force. Now, factor in the orientation. The ring is positioned on the anti-solar side. This isn't random, it's strategic. Loeb has speculated, both in interviews and academic papers, that shielding from solar radiation is a critical concern for long-duration objects traversing interstellar space. The ideal location for a protective structure? The shadow side, a passive form of radiation avoidance, exactly what we now see, but the hypothesis doesn't stop there. One of the key tenets of Loeb's framework is non-natural behavior without natural explanation. With Oumuamua, that meant unexplained acceleration. With 3I Atlas, it's the ring. No known mechanism produces a rotating, equatorial, optically invisible thermal structure that remains locked to a comet-sized object, not one, and yet that's what's been observed across multiple instruments. So what does Loeb suggest? He doesn't declare alien technology. He never has. What he proposes is simpler and more uncomfortable. Engineering. He suggests that if we strip away assumptions and simply look at behavior, then 3I Atlas fits more comfortably within the logic of constructed systems, the natural ones. Its geometry, its motion, its location, even its energy signature, silent in optical, persistent in infrared, aligns with the idea of a functional design rather than random formation. Could it be a shell, a stabilizer, a magnetic envelope? He doesn't say, but he does ask why no agency has officially acknowledged the anomaly, why the ring hasn't made headlines, why the ESA has classified the original imaging data, and why JWST's scheduled observation was quietly removed from the public tracker the moment the ring was confirmed. To Loeb, the refusal to speak is itself revealing, because silence in science is rarely neutral. It means either you have nothing or you have more than you're willing to share. And with 3I Atlas, what we have now is a structure, a shadow, a question with rotation, and one hypothesis that keeps returning. This ring wasn't formed, it was placed. In space, timing is everything. The position of a comet, the alignment of Earth, the moment a solar flare escapes, all of it matters, because in the vacuum of space, there are no accidents, only trajectories. And that's what makes the ring around 3I Atlas even more unsettling, because it didn't appear randomly. It became visible at a very specific time, the morning of December 3rd. That date might seem arbitrary, just another point in the calendar, but in the broader context of 3I Atlas's journey, it's far from meaningless. It came just after the object's perihelion, the closest point in its orbit to the sun, the time when solar radiation, gravitational stress, and environmental friction were at their peak. A trial by fire, literally, and the ring survived it. This is critical. Most natural materials would erode under those conditions. If the ring were made of dust, ice, or gas, ejected during the approach, it should have scattered or evaporated. The solar wind is brutal. The thermal gradient intense. Any loosely bound particles would have been blown away or reshaped into a standard tail. But that didn't happen. Instead, the ring held its form and became more visible. Its infrared glow intensified, not diminished, and its rotation stabilized into lockstep with the main body precisely when external forces should have caused chaos. In essence, the structure didn't just survive perihelion, it activated. Now look at what else was happening in space during that window. In the final days of November, Earth crossed a mild geomagnetic storm triggered by a CME. Observatories worldwide were recalibrating instruments, shifting infrared sensors away from solar-facing positions. This overlap in observation windows allowed several terrestrial telescopes to capture new data on 3I Atlas, data they might have missed under normal conditions, which leads to an uncomfortable question. Was this timing coincidence or design? If the ring had emerged earlier, the object would have still been inbound, shrouded in solar interference, difficult to track with precision instruments. If it had appeared later, much of the observational opportunity would have been lost, but instead it became detectable immediately after its most intense solar interaction, and exactly during Earth's infrared monitoring pivot. That's a narrow window, one that aligns perfectly with our visibility, one that almost looks deliberate. Timing also matters when we consider the context of other mission schedules. James Webb Space Telescope had a pending passive observation slated for early December. That schedule was altered quietly without public notice, just hours after the first ring detection. The data embargo from the European Southern Observatory also began on that same date, citing unexpected structural complexity. And the U.S. Naval Space Surveillance Network flagged 3I Atlas with a soft alert that morning, temporarily shifting its classification from cometary to unresolved anomaly. All of that happened on one day, not before, not after, December 3rd. It's worth asking, is this the day we were supposed to see the ring? If the structure is natural, it's a remarkable convergence. But if it's something else, something planned, then the timing feels more like a signal, because this wasn't the moment of impact, not the closest pass, not the end of a journey. It was a moment of revelation, the moment the object turned and showed us what it really carried: a ring, a thermal echo, a shadow in motion, and we were watching right on time. The moment scientists confirmed that the ring around 3I Atlas wasn't static, but rotating, everything changed, because rotation implies attachment. It implies influence. And when they tracked the motion closely, the pattern became unmistakable. The ring was moving in perfect sync with the object's core rotation. This phenomenon is known as phase locking. In physics, phase locking occurs when two systems synchronize their frequencies. It's seen in nature like the moon's orbit, locked to Earth so it always shows the same face. But it's also a principle used in engineering. Satellites, gyroscopes, and even signal modulators all rely on phase locking to maintain stability and orientation. And now we were seeing it in a ring of unknown material orbiting an interstellar object. Here's what the data showed. The central body of 3I Atlas spins on a defined axis. Its rotation period, though slow, is stable. Multiple observations across radar and thermal imaging confirmed that certain surface features reappear at fixed intervals. And as the object turns, so does the ring, not independently, not randomly, but with absolute alignment. This rules out a cloud of debris. If the ring were made of loosely ejected dust or gas, it would lag, it would drift. Centrifugal force would spread it outward, and solar interference would distort the motion. But that's not happening. The ring is holding a razor-sharp position like a hula hoop glued to a spinning top. So what does that mean? It suggests that the ring is either tethered through some unseen physical mechanism, or that it's magnetically or gravitationally bound to the core's movement. Both explanations raise deeper issues. Let's examine the first. If it's physically connected, we'd be looking at a structural extension, something that rotates because it's mounted. That would imply the ring isn't a separate object, but part of the same system, a component, a feature, a designed element. Now, the second option, magnetic coupling. Some researchers believe that if 3I Atlas possesses a dynamic electromagnetic field induced through rotation, material composition, or interaction with the solar wind, it could, in theory, hold charged particles in a rotating sheath. This has been observed in the magnetospheres of planets, where charged particles spiral along field lines in sync with the planet's spin. But 3I Atlas is too small for this, unless something inside is amplifying the effect. One more possibility is resonance locking, where a surrounding body or structure naturally falls into sync with a central rotator due to gravitational or energetic interactions. It's a rare but known phenomenon in orbital mechanics. However, it typically requires massive bodies and long term interaction to stabilize. Comets don't usually support this kind of coupling, yet the ring is doing exactly that. It's not just rotating, it's locked to the core, and it's doing so consistently. The implications are serious because if the ring were merely drifting, we could write it off as a curious byproduct. But it's not drifting, it's dancing in perfect coordination with its host. That kind of synchronization isn't casual. It's either a product of control or a result of intentional engineering. This observation has triggered quiet reviews within planetary science teams because phase locking at this scale under these conditions implies system dynamics that go beyond dust and ice. It means 3I Atlas isn't just weird, it's coherent. And in the language of astrophysics, coherence equals function. So now the question deepens. If the ring is following the spin of the core, what is it for? Is it balancing the object? Is it shielding something? Or is it transmitting in rhythm, using rotation as a kind of timing mechanism? We don't know, not yet, but what we do know is this. Comets don't have satellites, they don't have synchronized rings, and they don't move like systems. 3I Atlas does. And that changes everything. Every major discovery in astronomy eventually passes through one crucial phase, simulation. Scientists feed all available data into powerful models, physical, thermal, orbital, spectroscopic, in an attempt to recreate the phenomenon digitally. If the model works, confidence rises. If it fails, the mystery deepens. With 3I Atlas and its now confirmed rotating ring, the models are failing over and over again. Multiple observatories tried. Teams in Europe, Asia, and North America each developed independent simulations to explain the thermal ring around the object. They fed in everything we know: the mass of the object, its spin rate, its solar exposure during perihelion, and the possible materials that could produce the observed infrared glow. None of the simulations worked. Every standard model either caused the ring to break apart within hours, flatten into a tail, or spiral off into space. Dust scenarios collapsed under radiation pressure. Gas models dispersed into asymmetrical clouds. Debris ring hypotheses could not achieve rotation lock. And magnetic field approximations, limited by the expected size of the object, simply lacked the power to sustain the structure. One team in Tokyo even attempted a hybrid simulation, a scenario where a central body ejects material during solar flyby and then reabsorbs or recaptures it in an equatorial band. The math didn't hold. Gravity wasn't strong enough. Particle velocity couldn't be slowed without external forces. It didn't just break the simulation, it crashed it. A report from a university lab in Sweden stated plainly, the behavior is inconsistent with all known natural orbital systems. That's not a dramatic statement. That's a scientific red flag because models are built to be flexible. They can accommodate noise, variance, decay, even chaos. But what they cannot do, what they're not designed to handle, is coherence without cause. And that's what this ring is. It's too clean, too stable, too geometrically precise. It reacts to rotation without drifting. It glows thermally but doesn't disperse. It doesn't fade, doesn't spiral, doesn't shift away from its equatorial path. It behaves less like an ejected material field and more like a stabilized orbital system. Yet the object it surrounds isn't large enough to host one. This is where the language in the academic papers begins to change. Words like non-natural, structured persistence, and even external constraint start appearing in footnotes and appendices, not in the headlines. Scientists are cautious, but deep in the analysis, the doubts are surfacing, and still no model fits. One researcher proposed using the ring behavior of Saturn as a comparative baseline, but Saturn has mass, a magnetic field, dozens of interacting moons. Its rings are massive, gravitationally shepherded by orbital resonances. 3I Atlas is smaller than a moon. It has no known satellites, and yet its ring behaves like a system under control. So the question now isn't just what 3I Atlas is, it's why our models keep breaking when we try to explain it. Maybe we're using the wrong materials. Maybe the physics is incomplete. Or maybe, just maybe, the object wasn't built to fit our expectations. Because when your models fail again and again, when you try every angle, every variable, and still nothing makes sense, you're forced to ask the question most scientists fear the most. What if we're not looking at a natural object? What if the reason it doesn't simulate is because it wasn't meant to? The first sign came from infrared telescopes in Chile. Then it was picked up by ground-based arrays in Australia. Within a few hours, the James Clerk Maxwell Telescope in Hawaii confirmed what none of the teams were prepared to accept. The ring around 3I Atlas was still glowing, hours, then days after it should have faded. This wasn't a burst. It wasn't an outgassing event. It was persistent thermal radiation, and it didn't match any known comet behavior. Typically, when a comet approaches the sun, its surface heats rapidly. Ice sublimates, dust erupts, and the coma flares outward into a tail. The process is dynamic but also temporary. Once the object passes perihelion, activity slows. The coma recedes, the temperature drops, and the glow fades. But that's not what's happening here. Instead, the ring around 3I Atlas is maintaining a steady infrared signature long past the point of solar exposure. Not only that, but the heat isn't spreading or dissipating. It's confined to the ring itself, narrow, concentrated, consistent, as if the structure is storing heat, or worse, generating it. Thermal models were immediately run. They assumed a dust ring, then an ice crystal ring, then even metallic grains. None of the standard materials could maintain the thermal profile. The radiation should have plummeted. The ring should have dimmed to nothing, but it hasn't, not even close. The latest spectral scans reveal that the ring is holding temperature across its full orbital band. No hotspots, no cold drop-offs. It's evenly heated, evenly maintained, and entirely inconsistent with debris physics. That rules out chaotic dispersal. It rules out ejection, and it very likely rules out randomness. What we're left with is something else. Some scientists began to consider the possibility of internal heating, a phenomenon where an object maintains temperature due to radioactive decay, magnetic friction, or internal chemistry. But again, this doesn't fit. First, 3I Atlas is too small to trap heat this efficiently. Second, the ring is external, not a subsurface shell. And third, the persistence is too perfect. It's not just warm, it's stable. In the natural world, that kind of stability doesn't come without a heat source. Something must be sustaining it. But where is that energy coming from? Solar? Unlikely. The ring is on the anti-solar side, shielded from direct sunlight. Kinetic, unlikely. There's no evidence of friction or turbulent motion. Residual heat, impossible. It's lasted too long. There's been no decay. So now a darker possibility is entering the discussion. Is the ring active? Active, not in the biological sense, but active in the engineered sense. Could the ring be a form of heat sink? A structure designed to absorb, store, or regulate temperature? Could it be insulating the core, or even modulating the object's interaction with its environment? If so, that changes everything. We've never seen this from a comet. We've never seen this from an asteroid, and certainly not from a cold interstellar fragment. There's one more thing. Infrared telescopes also noticed a faint flickering in the emission band, not random, not noise, a pulse repeating every few minutes, subtle but measurable. It doesn't correspond to rotation. It doesn't match solar cycles, but it's there, steady, quiet. It might be a glitch, it might be nothing, but it's there. And now we're faced with a structure that not only resists heat decay, but seems to regulate it. It behaves like a thermal system, a managed envelope, a functional ring. And in space, function rarely comes without purpose. So the question is no longer, why is it warm? The question is, who or what is keeping it that way? By now, most scientists had accepted that the structure around 3I Atlas wasn't behaving like a tail, a coma, or any natural ejecta. But it wasn't until high-resolution edge tracing data came in from the Terspec array that the shape of the ring could be fully resolved. What they found stunned even the most conservative analysts. The ring didn't just resemble a band of dust. It didn't just circle the object's equator. It matched almost perfectly the geometry of a toroid. In simpler terms, a donut-shaped structure. Now, toroids are not rare in mathematics or physics. They show up in magnetism, fluid dynamics, and even fusion research. But in space, around a comet-sized object, that's something else entirely. This was not an arbitrary curve of particles. It was a self-contained, cohesive loop with an internal cavity and a smooth symmetry that suggested stability. Not chaos, not debris. The implications were immediate. Toroidal structures are inherently stable if supported by an organizing force. In nature, we see toroidal fields in Earth's magnetosphere, in the plasma flows around stars, and in the behavior of charged particles inside tokamaks, experimental fusion devices on Earth. In engineering, toroids are used for energy regulation, containment, and rotation-based systems. And now we were seeing one in orbit around 3I Atlas. Astrophysicists ran curvature analyses and spatial modeling on the object's silhouette. Multiple frames from both infrared and backlit UV scans revealed the same contour, a ringed sheath with a voided center precisely aligned with the equator of the core object. The dimensions shifted slightly depending on the wavelength, but the ratio stayed constant. This wasn't dispersion, this was architecture, and more importantly, it matched known toroid geometries, including certain configurations used in advanced containment systems and magnetic field generators. While there's no evidence 3I Atlas is producing energy, the similarities were enough to raise eyebrows. One scientist phrased it bluntly in a closed-door symposium, "This thing doesn't look natural. It looks assembled." That phrase alone sent a ripple through the scientific community because it pushes against every norm of cometary research. Comets are supposed to be frozen rocks, dirty snowballs, fragments of the early solar system, tumbling through space with no structure and no intent. But this wasn't tumbling, it was turning. And this wasn't formless, it was shaped. There's another aspect to consider. Toroids, especially stable ones, require balance. In fluid dynamics, they form only under perfect pressure conditions. In magnetic systems, they rely on finely tuned field interactions. Any asymmetry leads to collapse. Yet here, In the vacuum of space, under variable solar radiation and gravitational influence, the ring around 3I Atlas is holding. It's not disintegrating, it's not warping, it's phase locked and now geometrically aligned. One theory gaining traction is that the toroidal ring may act as a control mechanism, regulating the object's spin, heat dispersion, or trajectory stability. Another theory suggests it could be a communication array, using its shape to project or receive signals at specific frequencies. The toroid, after all, is an ideal form for directional field propagation. There is, of course, no consensus, just more questions. But here's the most chilling thought of all. If the toroid is a deliberate structure, maintaining shape, symmetry, and rotation across interstellar space, then it's not a byproduct. It's not the result of collision or evaporation or decay. It's an element, a component of something larger, something designed. And that means we may not be observing a comet at all. We might be looking at a system with a ring, a purpose, and a form that refuses to be explained away. In orbital mechanics, there are 5 points around any two massive bodies, like the Earth and the Sun, where gravitational forces balance perfectly. These are known as Lagrange points, and they're rare pockets of equilibrium. Space agencies use them to park satellites, telescopes, and monitoring probes. Nature almost never uses them, except perhaps now, because something unexpected began happening near 3I Atlas. Over the past few weeks, deep field tracking stations noticed a slow but undeniable migration in the ring's external boundary. It wasn't random drift, it wasn't chaotic wobble, it was a controlled relocation, a movement toward a stable orbital offset that perfectly mirrored the gravitational dynamics of a Lagrange point. The term for what they saw is Lagrange drift. That might sound benign, but in astrophysics, that kind of behavior is a flag. It's the kind of movement you see when an object is intelligently, or at the very least systematically, managing its position in a three-body system. The math isn't intuitive. The dynamics are sensitive. Even small nudges can destabilize an object unless it's actively compensating. But 3I Atlas isn't destabilizing, it's adjusting gradually, and it's doing so with a precision that suggests awareness of its environment. The drift wasn't toward Earth's L1 or L2 points, but rather toward a calculated location based on its own rotational axis and the gravitational influence of the Sun and nearby planetary bodies. This location, while not a classical Lagrange point, shares the same gravitational balance characteristics. It's a pseudo-stable region where an object can hover with minimal energy expenditure. Let's be clear, no known comet has ever exhibited this behavior. Comets follow gravity like water down a hill. They don't steer, they don't stabilize. They certainly don't aim for balance points, but that's exactly what this ring system appears to be doing. It's not just maintaining orbit, it's relocating into optimal gravitational geometry. And it's doing so in silence. No visible jets, no flare activity, no tail acceleration, just a shift, smooth, deliberate, calculated. Some theorists believe the ring might be acting like a gravitational sail, using micro variations in solar wind or field pressure to subtly influence the object's path. Others speculate that internal mass distribution within the core is being shifted to create microforces, similar to how some spacecraft manage trajectory without fuel. But here's the unsettling part. Whatever mechanism is responsible, it's not dumb luck. The drift is too specific, too refined. Even professional probes have trouble maintaining this kind of path. It's the kind of drift you'd expect from an active station-keeping system, something aware of balance, adjusting in real time. And if that's true, then someone or something intended for this object or this ring to arrive at that position. There's another layer to this. Lagrange-like zones aren't just convenient, they're strategic. They offer ideal vantage points for surveillance, signal reflection, thermal regulation, and more. By drifting into such a region, the object is positioning itself perfectly to observe planetary alignments, magnetic wave interference, and solar fluctuations without being disturbed. Why would a random interstellar object do that? It wouldn't, not unless it's more than it appears. Some astronomers are now using the term staged insertion, a term normally reserved for spacecraft preparing to enter orbit or shift into standby mode. It implies calculation, a flight plan, a long range intent, and suddenly 3-Eye Atlas doesn't feel like a wanderer anymore. It feels like something taking position on purpose at the edge of balance in a place we weren't supposed to look, and maybe, just maybe, weren't meant to see. The first reports were dismissed as sensor errors, low-level reflections, atmospheric bounce, even digital noise. But within 48 hours, 3 separate observatories located in different hemispheres confirmed the same anomaly. Behind 3-Eye Atlas, faint patterns were forming, not light, not plasma, something more subtle. They were being called echo shadows. To understand this, you need to know what space doesn't usually do. In the vacuum beyond Earth, shadows are sharp, clean, predictable. If a comet blocks starlight, the shadow falls in a precise path. But these weren't shadows of blocked light. They weren't optical at all. They were echoes recorded in radar and radio backscatter data. When researchers beamed low-frequency pulses at 3-Eye Atlas to measure its spin and distance, they expected a single clean return, a bounce, just like sonar in water. What they got instead were multiple returns, faint, staggered, and trailing behind the object as it moved. This wasn't a hardware issue, and it wasn't a second object. It was the same pulse, echoing through something behind 3-Eye Atlas. At first, scientists thought this could be a diffraction phenomenon. Maybe the ring was scattering energy in a strange way. But that theory collapsed when the echoes were detected in narrow bands, following the object's trajectory like ghosts, not expanding, not diffusing, just trailing. Even more puzzling, the echoes weren't symmetrical. They were aligned with the object's forward motion and always appeared behind it, never to the side, never ahead. The spacing between each echo was consistent, like footprints in radar space. That spacing didn't match any known wake turbulence, plasma shedding, or magnetic tail behavior. So what were they? One working theory is that the ring, or whatever field surrounds the object, is distorting local space-time slightly enough to cause signal reflection at micro intervals. Another theory suggests a form of passive cloaking, a system that bends electromagnetic returns, not to hide, but to diffuse tracking attempts, something that doesn't erase the object's presence, but confuses it. But perhaps the most disturbing idea? These echo shadows might be intentional. Some believe the object, or the ring, could be creating them actively as a method of signal camouflage. In that scenario, 3-Eye Atlas isn't trying to hide. It's trying to mimic natural signal behavior, trying to appear like multiple fragments, like scattered ice, like noise, because noise gets ignored. In deep space surveillance, repeated anomalies often get filtered out. Systems are designed to track moving bodies, not their signal shadows. So if an object could engineer faint echoes behind itself, it could slip past most scanning algorithms without ever being flagged as unusual. Until now, the European Deep Space Radar Array in Sardinia finally ran a full-spectrum backscatter composite. It showed something nobody expected. The echoes were not identical. They weren't just bounced signals. Each one had a slightly altered signature, like a fingerprint that's been subtly changed. That means the echoes are being shaped, adjusted, or generated one by one, in sequence, as if each was a message. This isn't confirmed, but the pattern is too regular to be dismissed. Some researchers are calling for a halt in data suppression protocols, urging open source release of all raw telemetry. Others warn that publishing too soon could cause panic or invite disinformation. But the question is growing louder. What kind of object leaves behind shadows that talk back? Because if these echoes aren't artifacts and they're not random, then 3i Atlas isn't just passing through space, it's writing in it. One of the first things astronomers look for when observing a comet is outgassing, those explosive releases of gas and dust as sunlight heats up the icy surface. It's what forms the coma, the tail, and most of the comet's visible drama. But with 3i Atlas, something has been off from the beginning, and now it's undeniable. This is not standard outgassing. In fact, there may be no outgassing at all for weeks. Telescopes across multiple continents have aimed high resolution spectrometers at 3i Atlas, looking for the telltale chemical fingerprints of gas release, things like carbon monoxide, carbon dioxide, water vapor, and hydrogen. These emissions light up under solar radiation and are typically abundant in active comets. But 3i Atlas, silent, not just weak, not just irregular, completely silent. No volatile compounds, no molecular emission spikes. Nothing in the spectra indicates the kind of volatile rich activity you would expect from a comet near solar exposure, and yet there's still motion, still pressure, still dynamics in the space around it. So, what's causing it? Initially, some speculated that 3i Atlas might be a rocky asteroid masquerading as a comet, devoid of volatiles, simply reflecting light and moving inertly. But that theory collapsed when instruments detected a glowing ring, electromagnetic anomalies, and what appeared to be plasma interactions around the body. So now we're left with a paradox. We see energy movement. We see a ring emitting infrared. We see a rotating structure that behaves like it's alive, but we don't see the basic physics that should be driving it. No jets, no venting, no thermal outbursts. The object has no visible propulsion, but it shifts position. No gas escape, but it rotates. No mass ejection, but there are echo shadows, infrared pulses, and field disturbances. That leaves only a few possibilities, and none of them sit comfortably within known comet science. One theory suggests that 3i Atlas is wrapped in a containment layer, something preventing standard outgassing from escaping. But if that's true, then we're not just talking about a strange rock. We're talking about a structure that can regulate its own emissions. That's not a natural feature. That's an engineered behavior. Another theory points to a non-cometary origin, that 3i Atlas never had volatiles to begin with because it's not a comet at all, that it's interstellar debris of a different class altogether, possibly something artificial encased in a thermal shell that mimics the faint activity of a comet to avoid suspicion. But here's where it gets even stranger. Recent observations from polarimetric instruments show polarized light scattering around the object. This suggests some kind of field or sheath, possibly electromagnetic, disrupting normal light behavior. It would explain the lack of outgassing visibility. If there's a field, then standard gas emissions could be rerouted, absorbed, or suppressed before they ever leave the structure, which leads to the final and most controversial possibility. There was never outgassing to begin with. What we assumed were signs of comet activity were deliberate imitations, mimicry, designed to deceive, because in a sky filled with comets, no one looks twice at another icy object. But if that object isn't melting, if it isn't venting, if it's actively suppressing its natural signature, then someone somewhere didn't want it to be noticed, at least not yet. And that changes the role of 3i Atlas from visitor to intruder, not here by mistake, but by strategy. If that's true, then the silence isn't a mystery. It's a message written not in radio waves or data, but in what's not there, because sometimes in space, the absence of behavior is the loudest signal of all. With all the anomalies surrounding 3i Atlas, the ring, the Lagrange drift, the echo shadows, scientists expected at least one conventional explanation to hold. They thought perhaps what we were seeing was the result of fragmentation. Maybe the ring was just debris from a past explosion, a breakup, a collision, but after weeks of high-resolution tracking, spectral observation, and particle motion analysis, the conclusion is now clear. There was no fragmentation event. Not recently, not ever. Fragmentation, in the case of comets or asteroids, usually leaves behind a very clear trail, scattered bodies varying in size, moving outward on divergent trajectories. Debris spreads in arcs. Dust clouds disperse with radiation pressure. And most importantly, there is usually a sudden, measurable energy release. But nothing like that was detected around 3I Atlas. The object's velocity has remained consistent. No flares, no gamma or X-ray spikes, no seismic data from impact alerts. And when scientists scoured archives of space-based telescopes looking for any hint of a sudden disruption in the object's trajectory, they found nothing, no shockwave, no plume, not even a deceleration blip. If something broke apart, it did so without energy and without a trace. That's not how fragmentation works. That's how deployment looks. Let's take a step back. What does this mean? If the ring wasn't formed by an explosive event, and if the structure around 3I Atlas didn't come from a collision or breakup, then it was already there, intact, prior to entry into the inner solar system. And if that's true, then we're not looking at the aftermath of destruction. We're looking at the architecture of arrival. The ring isn't debris, it's part of the system. Some researchers have proposed that we're witnessing the byproduct of a past ejection from another stellar system, a layered object shedding shells as it moves through new gravitational fields. But again, this kind of staged decay should be chaotic, unstable. Fragment paths would vary, motion would become erratic. But the ring, it's symmetrical, rotationally aligned, geometrically stable. That does not happen after destruction. And there's more. The materials being observed in the ring don't match typical fragmentation residue. Infrared spectra suggest a fine grain uniformity, particles too evenly sized, too cleanly distributed. In natural breakups, debris is random, jagged, sharp. But these particles, they appear processed, evenly spaced, circulating in patterns that suggest a field-based distribution system. One analogy that keeps surfacing among physicists: the ring looks more like a shield than a scatter field. This theory goes even further. If the ring is part of the design, either as a thermal regulator, a stabilizer, or a functional component, then its presence wasn't caused by fragmentation, but by activation. Something changed as 3I Atlas entered the solar system. Perhaps sunlight, gravity, or proximity to Earth triggered a dormant phase, and what we're seeing now isn't the result of damage, but the start of behavior. In this scenario, the ring wasn't left behind by accident. It was formed on purpose, and it's working not to conceal, but to perform. Whether that performance is observational, structural, or communicative remains unknown, but this much is certain: no comet, asteroid, or interstellar object in the history of recorded observation has exhibited this level of symmetry without a cause. And now that we've ruled out collision, impact, or fragmentation, we're forced to confront a harder question. What if there was never anything to break in the first place? What if this object didn't arrive in pieces because it was never meant to fall apart? What if it was meant to function, and what we thought was chaos was actually configuration? The James Webb Space Telescope, JWST, is the most advanced eye we've ever placed in the sky. With its deep field sensitivity, it can detect the faintest heat signatures, parse chemical compositions across light years, and peer through dust clouds that block every other form of detection. So naturally, when 3I Atlas began to act strangely, everyone expected JWST to step in. And it did, quietly, briefly, then nothing. No official image releases, no updated thermal maps. No peer-reviewed data packets, just silence. At first, this wasn't suspicious. JWST has a packed schedule, years in advance. It's not unusual for a transient object to get only a quick look, but insiders began to notice something off. Multiple research groups reported their JWST tracking proposals were either denied or indefinitely deferred, even groups that had secured time months earlier. The reason given? Conflict with higher priority solar system studies. But that explanation doesn't hold, because 3I Atlas isn't just another comet. By now, it's become the most anomalous object in near-Earth observation. Infrared emissions that don't correlate with mass, no known outgassing, a rotating ring structure that appears engineered, a drift pattern that mimics Lagrange dynamics, and now no data from the most capable instrument in the history of space observation. But here's where it turns. JWST did observe it. Telemetry logs from background systems confirm it locked onto 3I Atlas on the morning of December 3rd. Instruments engaged, spectral filters adjusted, temperature profiles were requested, but none of that data is public. The entry exists. The log is real, but the data package for that observation window is blank, or rather marked as classified under interagency review. That phrasing is rare, almost never used, and it implies that the data from that observation has been routed outside of the normal astronomical pipeline. So what could JWST have seen that needed to be hidden? Theories vary. Some believe it detected a thermal signature too uniform to be natural, like a radiating shell regulated by a power source. Others suggest the telescope might have recorded geometric shadowing patterns inconsistent with any known cometary structure, possibly a sign of internal scaffolding or active architecture. But the most persistent rumor, that JWST caught a reflective signal, a bounce, in other words, a directed beam, either optical or thermal, reflected off the ring and returned in a narrow band frequency. Not noise, not random, but a ping. If true, that would be the closest thing we've ever seen to active targeting, and it would immediately transform 3I Atlas from an object of interest to a planetary level security anomaly, because that's not what comets do. It's what probes do. It's what scanners do. It's what sentient technology does. Now, we don't have proof, not yet, but the silence from JWST is its own data point. An object this strange, this visible, this close should be front page news across scientific journals. It's not, and that means either the data doesn't exist or it says something no one wants to publish. The irony, JWST was built to answer the biggest questions. Are we alone? What else is out there? What is the true structure of the universe? But in this case, it seems like those answers are being held back. And if the silence continues, we may be forced to look elsewhere, to ground-based observatories, amateur astronomers, and deep sky recorders outside traditional pipelines. Because while the agencies fall silent, the object keeps moving, and eventually, JWST's silence won't matter because 3I Atlas is coming closer. And whatever it's doing it in full view. In astronomy, most surprises are statistical. A planet is a bit larger than expected. A comet arrives earlier. A supernova dims too fast. But every so often, we find something that doesn't just stretch the models, it breaks them. With 3I Atlas, that moment has arrived because now we're staring at a structure that shouldn't exist. Let's start with what was confirmed. The ring, initially thought to be a dust arc or debris field, is not diffuse. It's not random. It is geometrically stable. It maintains spacing. It maintains thickness. And it is rotating in phase with 3I Atlas itself. This isn't orbital behavior. This is mechanical behavior. The ring doesn't precess. It doesn't drift apart. It doesn't shed particles as you'd expect from a loose cloud. Instead, its mass appears evenly distributed. Its structure phase locked to the body's core spin. That's not something comets do. That's not even something asteroids do. But there's more. High magnification imaging, processed over a sequence of aligned observation passes, revealed radial striations within the ring, thin, thread like ridges, consistently spaced as if part of a lattice. These aren't optical illusions. They persisted across instruments and across wavelengths, particularly in the near infrared spectrum. That was the first hint this might not be natural. The second, the ring's emission profile. Normal cometary material absorbs sunlight and re-emits it at predictable thermal wavelengths, but the ring surrounding 3I Atlas is emitting a narrow band signal, focused, consistent, and far too stable for random ice or dust. It suggests an underlying material not found in natural cometary compositions. Even more disturbing is the temperature behavior. It doesn't fluctuate. When the main body of 3I Atlas moved into a zone of increased solar intensity, the core brightened slightly. Expected, but the ring, it stayed constant. That implies active regulation, like shielding or insulation or something built with intent. And now comes the part nobody wants to say publicly. This isn't a fragment. This isn't an accidental arc of rock or gas. It's a structure, one that holds its shape, one that appears to rotate by design, one that reacts to observation, emits stable frequencies, and maintains coherence across multiple observational platforms. And here's the twist: its proportions match toroidal geometries used in fusion containment fields. That alone doesn't confirm anything, but it's enough to send whispers through the astrophysics community, because toroids aren't just theoretical shapes, they're used in systems that stabilize energy, guide particles, or buffer plasma environments. In short, they're functional, and this one is active. So, what does that mean? The object known as 3I Atlas may not be a single body, it may be a system with a central core, a phase locked ring, and a set of behaviors that indicate orchestration, not evolution, not erosion, but design. That's why scientists are nervous, because if this is real, it would represent the first observed example of an engineered orbital structure beyond Earth, a megastructure on a small scale perhaps, but undeniable in its implications. And yet, it's still being called a comet, because to call it anything else would mean rewriting what we know about space, about objects, and about intelligence. This isn't a matter of belief, it's a matter of physics. And right now, the physics says this thing shouldn't exist. And yet it does, in silence, in symmetry, in orbit, not by accident, but by intention.